In this video, I'm going to introduce the concept of logarithms. But just before we do, I want you to have a think about a few things first, and in particular, inverse operations. If I was to ask you to solve, for example, x squared equals 36, you would turn around and say, well, okay, that's great. I can take the square root of both sides. Okay, so x is equal to plus or minus the square root of 36, which is plus or minus 6. Okay, let's think of some other straightforward examples. If, for example, 3x is equal to 12, you would turn around and say, well, okay, well, that's easy enough. I could make x the subject of the formula, and I can divide both sides by 3, and I could express it as 12 over 3, and that's equal to 4. Okay. Let's think of something else. For example, addition and subtraction. If x plus 2 is equal to 8, of course we could make x the subject of the formula. X is just equal to 8 minus 2, which equals 6. Okay. What if though we had an equation like this? For example, 3 to the power of x is equal to 100. How would we make x the subject of the formula? In fact, how would we solve an equation like this? So have a think about that for a moment. This is the first time you probably have seen an equation like this, in fact, where the index is unknown and we need to somehow find a way to make this x the subject of the formula. And I think this is where this is a good time to introduce the idea of the inverse of an exponential, okay, or the inverse of exponential form. So if we could rewrite this in a different way, or in such a way that we could make x the subject of the formula, then we may have a way of being able to solve this kind of an equation. So look, you can at the moment. You can try some guess and check methods if you want. 3 to the power of 4 is 81, so it'll probably be 3 to the power of maybe 4.2. Now get 100.9, but it's not exact. But could we solve this equation so that we get a fairly precise answer? Okay, right. So I'm just going to put this next board there, where we'll talk about the concept of a logarithm, and we'll take an example. So this is the number 125 expressed in exponential form. 5 to the power of 3, we can agree, is 125. The 3 is what's important. Remember that last equation where it had the x was the index. We could write this in a different way. Okay, we could rewrite it using what we call logarithmic form, okay, or in the form of a logarithm. So a logarithm looks like this. We start off with the word log. Okay, the little number after the log is in fact the base. Okay, so if you recall from indices, okay, the large number here, this is called the base. Okay, and the base actually has to be greater than 0, by the way. It has to be positive. Okay, we don't deal with negative bases in this topic. So it doesn't make too much sense. Okay, the 3, okay, well, that's the index. Okay, could be called the exponent or the power, or there's a few words to describe that, but we'll just call it the index for now. So 125 is just the simple number. So the logarithm looks, uses the same numbers but in a different way. The little 5 here, that's the base. So this 5 corresponds to this 5 here. The 3, if you notice, the 3 is now the subject. Okay. So in other words, 5 to the power of 3 gives you 125. So it's sort of a good way to think of that. Okay. So 5 to the power of 3 gives you 125. But it allows us to rewrite this equation, okay, or this expression, 5 to the power of 3 equals 125, in such a way as to make the index the subject of the formula. And that allows us to be able to solve some very, very useful equations. For example, compound interest. If I was to ask you a question, let's say at 3% per annum, that is an investment at 3% per annum, compounded monthly, how long would I need to wait for the investment to triple in value? Okay, and answer to for example, to the 2 decimal places. So I want it fairly accurate. So you're not going to be guessing and checking your way through this. You'll be there for a while. We need to have a sure method of being able to get to the answer, get to the solution in one go. Okay, we've looked at some of these examples already of inverse operations. So a logarithm is the inverse of an exponential. Okay, so if you want to sort of reverse an exponential, we can use a logarithm. And if you want to reverse a logarithm, we can use an exponential. Okay, so I'm not going to go through these examples. You could read them for yourself there. So let's move on to just some more general logarithms now. So if a to the power of m equals x, okay, it's like that 5 to the power of 3 equals 125. Okay, so I might just rewrite this here. So e.g. 5 to the power of 3, if that's equal to 125, okay, then log of base a, the base in this case would be 5, the log of base a of x, or the log of base a of x will equal m. So in this example, okay, log of base 5 of x, which is 125, equals the index that you raised the 5 by to give you the 125. So that would be 3. So that would be the index. So a logarithm really is an index. It gives you back an index that you can then raise the base by to give you the simple number. Okay, and likewise with if you start off with a logarithm, you can rewrite it back into index form, and we've looked at this already. So if you had a log of base b of y giving you n is an index. So in other words, b, okay, to the power of n gives you y. b to the power of n gives you y. Okay. Now we've stipulated that the b here has to be positive. Okay. Now we've said that already. The y has to be positive as well. Okay. So I didn't say that in the last slide, but the y also has to be positive. Okay. So it doesn't make sense. Actually, it's a good question. Why does it have to be positive? In fact. So I'll leave you to have a think about that. Now we can talk about that in another video. But why is the y positive? No pun intended. And also, why is the base positive? Could we have a negative base? Maybe, maybe not. You can have a think about that for yourself. We can talk about that later. Let's have a look at some examples. So example A, we've got we have to evaluate each expression. So log of base 6 of 36. So the question then, how would I would rephrase that question. What would I raise the 6 by to give you 36? Okay, and the answer for that would be, well, if you know your square numbers, and 36 is a nice square number, the answer there would be 2, because 6 to the power of 2 gives you 36. What about this one? Log of base 10 of 1,000, or log base 10 of 1,000. What do you raise the 10 by to give you 1,000? Okay, so 10 to the power of what, okay, gives you 1,000. So in fact, well, 3 zeros, the answer there would be 3. And you can check that on your calculator. 10 to the power of 3 will most certainly give you 1,000. These ones here, we're going back in reverse. So we've got exponential form, okay, and we want to write those into logarithmic form, okay. So 2 to the power of 8 equals 256, fine. How can we rewrite that using the logarithmic expression or logarithmic form? We start off with the word log. The next thing is the base, okay, so I'll just slide that board up a little bit. The base is 2, okay, so we know what that is, 2 there, okay, of the simple number, which is 256, would give you back the index, okay, and the index is 8. That means 2 to the power of 8 will give you 256. Or log base 2 of 256, what power would I need to get the 256? The power would be 8. What about this one? 10 to the power of negative 1 equals 0.1. Yes, the indices can be negative. That's okay. We've studied negative indices before. We know what a negative index is. Okay, it's basically fraction form, reciprocal form. Again, start off with the word log. Okay, what's the base? The base is 10. Okay, the simple number is 0.1. And the index is negative 1. And again, that makes sense. 10 to the negative 1 is really just 1 on 10, which is 0.1. So it's you need to be able to sort of think about it in not just in the forward direction, but in the reverse direction as well. And the last one here, 3 equals 27 to the power of a third. Well, that's a cube root of 27. So of course, 3 times 3 times 3. Let's write that in log form, okay, or logarithmic form. Write the word log. The base is 27, okay. The simple number is 3. And the index, okay, which is the subject of the formula, the index is 1/3. And that's how we then convert exponential form into logarithmic form.